In this segment, we'll look at the more modern, though not quite yet universally supported, Flexbox method for doing liquid layouts. HTML5 introduces a new style feature, the Flexbox, that lets you easily set up horizontal or vertical sequences of HTML elements with specifications for which elements are to be expanded or contracted, if the overall space for the sequence grows or shrinks, along with other rules regarding element sizing and alignment. This makes Holy Grail layouts much simpler and allows other sophisticated layouts that are not possible with earlier HTML and CSS. The example fbgrail.html supplied with this lecture uses flexboxes to produce a Holy Grail layout as demonstrated right here. We'll be looking at the HTML and CSS for it shortly. First, though, as with the prior segment, I'll ask you to read up on flexboxes from a good online reference. But since there's no online flexbox reference that's as good as Levine's article on three-column layouts, we'll do some preliminary discussion first. So a bit of history. The concept of flexboxes is only new to HTML and CSS. Flexboxes are similar layout systems, and I'll show a little diagram here of the things we're going to be talking about. This is kind of a flexbox layout arrangement. These things have been around and in use for about 2 decades as of this writing. And it's a bit pathetic that it's taken until 2013 for them to appear in HTML and CSS. If you've used Java Swing's box layout, perhaps, or the more recent Android linear layout, then flexboxes will be quite familiar. And conversely, learning HTML flexboxes will make it easier for you to learn similar features in other GUI libraries. It's a common concept. Systems for laying out GUI elements have evolved over the past century, and the history of that development has seen a number of powerful and often overly complex layout systems. Java's grid bag layout is perhaps the king of the complex layouts. It offers a quasi-grid arrangement, a sort of HTML table writ large, with so many rules that there are entire websites and online lectures devoted to explaining it. But such layouts are dinosaurs. After all the dust has settled, it turns out that simple linear layouts, like flexboxes, can do almost anything you need, if you nest them inside of one another, as we'll be doing. Now, unfortunately, the HTML flexbox standard itself has seen some evolution, shall we say, over the past several years. And it's only recently that the field settled on a standard set of flexbox style properties and naming conventions. The result is that there are a number of older, browser-specific versions of flexbox style lying around, and while the final standard is now fully implemented in all recent version major browsers, several of them still use browser-specific flexbox property names instead of the standard names. For instance, the standard property display flex, as you can see in our diagram here, is display-webkit-flex in Chrome, and in IE it's display-ms-flexbox. This isn't perverseness on the part of the browser developers, it's just that they implemented flexboxes before the standard was formalized. Browsers ignore styles they don't recognize, so the convention is for each browser to use dash prefix keywords for styles not yet standard, so as not to bother the other browsers. This is a nuisance, but as we'll see, it can be worked around, and by the end of 2013, it's likely to be gone once all browsers implement the Flexbox standard as specified. So, with that prologue, let's look at the fbgrail implementation of the Holy Grail 3-column layout using a Flexbox. Our HTML is the same as before, with a left and center and right column, and headers and footers. The left, center, and right columns are in their natural order in the HTML, however. Flexboxes don't require the odd ordering that the earlier solution did. And by the way, I have dropped out some lines here and abbreviated others just to make the thing more readable, thus the line gap between 13 and 20. These line numbers reflect the actual file without compression. Now the CSS is quite changed. We'll start with the style for container. The line display:/flex sets container up as a flex container, an HTML element that contains children to be laid out per Flexbox rules. Now, the next two lines as we described a moment ago, do the same thing, but using the browser-specific display values for Chrome and for all of whose browser-specific flexboxes start with -WebKit-, and for IE, all of whose start with -MS-. These latter two lines, as we said earlier, will be unnecessary by the end of 2013, but for the present, each one-line flexbox style will become a three-line style paragraph, covering the special flags needed for Chrome and IE. Firefox, by the way, already implements the standard without special flags. From here on, I'll assume that's understood, and we'll talk only about the first line of each three-line paragraph. Now, the layout of a flexbox is a cooperative effort between the flex container, and let's use our little diagram here, thus, and the flex items within it, the child elements of the parent flex container. There are a number of flexbox layout parameters, each one set by different style properties in either the flex container or the flex items. Here's a summary of most of them below. Be ready to look at the details of each of these properties when you do the reading. We'll have in-lecture questions on a number of them. So, things the flex container determines are first. The flex container determines whether the layout is vertical or horizontal. Horizontal is the default. The flex direction style property, and of course its Chrome and IE variants, gives you other choices. Now, this also determines what is called the main axis of the layout. That's the x-axis for horizontal layouts, as here, or the y-axis for vertical layouts, like here. The next thing that the flex container can determine is how the flex items, the children here, are spaced out on the main axis when there's more room than needed for them. This is termed justification. For a horizontal, and you can substitute in vertical as appropriate here, for a horizontal flex container, they can be packed toward the left if you wanted, or to the top of a vertical container, that would be. They can be spread out evenly instead, or even packed toward the right if you want. Even spread out is a fairly common alternative, and there is how that would look. And of course, in a vertical case, that would be toward the bottom or evenly spread out, as the case may be. The style property justify content controls this, style property of the flex container. Now, since we'll have any extra room on our main axis, the x-axis in our case, filled by the expanding center column, this property doesn't actually matter in our example. There will be no extra room. But it does in cases where the flex items aren't expandable, for instance, a set of images. Now, the third thing that a flex container can determine is how the flex items are arranged along the cross axis. That's the axis perpendicular to the main axis. This is termed alignment, as opposed to the earlier justification. For instance, if we have flex items of different height in a horizontal layout, then we may want all their top edges lined up, or all their bottom edges lined up, as the case may be. So that's one possible alignment there, kind of loosely lining them up anyway. Or maybe the alternative to align them along the bottom edges, like that. Or we could have them centered vertically, so that they all line up on the same center line, roughly. Thus. Now, similar choices exist, of course, for left-right alignment in a vertical layout, where the cross-axis is instead, of course, the horizontal. Thus, the style property align items controls this behavior, and the default is to stretch the shorter flex items as needed to make all the flex items the same height or the same width for vertical layouts. This is fine for our purposes. All three columns ought to be the same height, so we'll just leave that style as the default. By the way, this main versus cross distinction is used a lot in Flexbox documentation. For instance, the main size of a flex item is its size along the main axis, and its cross size, of course, is the size along the cross axis. At least one of the references includes a pretty diagram like the ones I've got here, but better, to help remember all that. Use these or watch for that diagram. Now, the fourth thing that a flex container style will determine is whether the flex items should be broken into multiple rows, or multiple columns, in the vertical case, if there is insufficient room for them along the main axis. The style property FlexWrap controls this. The default is not to break into multiple rows or columns, but instead to shrink the flex items down as needed to fit along the main axis. So if we were to squeeze this thing, for instance, down so that these flex items didn't have room within, they would also themselves be shrunk down to make the necessary room to fit them in to the flex box, kind of like that, and squeezed. Thus, right? Now that behavior is actually fine for our example, but if we had, for instance, a center panel with a series of images on it, we'd probably rather that they break into multiple rows without changing their size as we squeeze the display down, rather than having the images be truncated or X-scaled in odd ways. Let's put that back the way it was. And that is the list of things that the flex container determines. Now let's talk about what the flex items determine. So the following are layout parameters determined by the style properties of each flex item individually. First, how much extra space the item gets if there is space to go around. If there's extra room along the main axis, different flex items may expand to different degrees to use up that space. The numerical style property FlexGrow, which each flex item sets independently, determines this. The default FlexGrow value of 0 results in no expansion by the item. Positive values result in a flex item getting some of the extra space, with the space divided up based on the FlexGrow values. Higher values get proportionally more space. In a sense, it's as though the flex items bid for extra space via their FlexGrow style properties, with higher bids getting proportionally more space, and a bid of 0, of course, getting no extra space. Now, for our 3-column example, we set FlexGrow to 1 for the center column, and we'll be talking about that in a bit more detail. The flex property we actually use subsumes FlexGrow and 2 others, as we'll see. And the result of setting it to 1 for the middle column and leaving it defaulted to 0 for the left and right columns is that the middle column gets all the extra space. Now, the next thing that the flex item properties can determine is how much to shrink if there's too little space along the main axis. This is a different issue from how much to expand. A given flex item might be happy to expand if there is room, but not willing to contract at all. A different numerical style property, FlexShrink, governs how much of the burden of shrinking each flex item takes. And flex items shrink in proportion to their FlexShrink value, with the default of 1, not 0, for all flex items, resulting in equal burden sharing. Now, if all flex items antisocially set FlexShrink to 0, then the flexbox content simply doesn't shrink, though the flexbox itself may shrink to a size too small to show all its content, and then its overflow property determines whether content is truncated or scrolled per usual for HTML CSS. In our example, the center column is the good citizen with a flex shrink of 1. Now, the third thing determined by flex item properties is the preferred main size along the main axis of the flex item. Remember, the main size would be this direction. If we're going to be growing or shrinking flex items, it's a good idea to know what main size they prefer as a starting point. The flex basis property determines this. It takes the same value as width or height, the same kinds of values, I should say, as width or height. For instance, 100 pixels or 55%. Or also a special auto value that is the default. Auto sets the preferred main size to whatever minimally accommodates the content within the flex item. The fourth thing that flex items can determine is the order of appearance within the Flex container. Now, Flex items normally appear in the order they're listed in the HTML, just as you'd expect. But it can be useful from a design standpoint to list Flex items in one order in the HTML, but override that to cause a different order of appearance in the display. You can do this by setting the order style property for each Flex item. Flex items appear in ascending order of their order style properties. Ties are broken, by the way, by using the order of appearance in the HTML source. So the default order value, which is 0 for all Flex items, reverts to the standard HTML order behavior. The fifth thing that the items can determine is whether they want to override the align items decision made by the Flex container. The Flex container, recall, determines how items are aligned along their cross-axis collectively. But setting an alignment, a cross-axis position, for all Flex items collectively can sometimes be too broad, and one Flex item might want to align to the beat of a different drummer, so to speak. Perhaps a logo image at the start of a horizontal Flex container should be center-aligned, while Flex items after it are aligned to the top. The non-conforming item can do this by setting its align self property, with the same value choices as for align items. And then sixth, Flex items can set Flex Grow, Flex Shrink, and Flex Basis all at once. These three style properties go together, and they may be selected collectively via the aggregate Flex property, as in our example CSS here, for the left and right, and also for the center divs, the columns. Now, the three values following Flex, for instance, 1, 1 auto in our center columns style, are the Flex Grow, Flex Shrink, and Flex Basis values, respectively. And perhaps 99% of Flex values are one of three patterns. 1, 1 auto. This is the good citizen setting. It takes its share of both any extra space and any shrinking. 0, 0 auto. That would be the antisocial don't mess with me setting, refusing to budge from its optimal size. This is also settable as none, as for our left and right columns. So they are behaving antisocially in our example here. 0, 1 auto. Now, this is the very good citizen, I don't need any extra space, but shrink me if you need to setting. And unsurprisingly, this is also the default. The above lists cover almost all the style properties you'll ever need for Flexboxes. But in case you want more, there are a few obscure ones I omitted, plus lots of detail on the values for the properties we did cover, all in the references. Now, this lecture is not a Flexbox reference, it's just an introduction to the broad ideas. In the next segment, we'll have a few in-lecture questions on Flexboxes, ranging from simple to quite challenging. For these, you'll want a reference or two, and there are plenty of decent ones online. So now's the time to read the bibliography supplied Flexbox references, or others you may prefer to hunt up on Google, get more details on Flexboxes, and bookmark the pages you like best. Please spend at least 20 to 30 minutes doing so before starting the next segment.